Hello everyone, this is Amit. I welcome you all in the video lecture series of the subject Operation Research. This is our third lecture related to the chapter Transportation Problem. In our third lecture, we will study about the method that is least cost method, which is used to obtain a basic feasible solution. Hello everyone, this is Amit Utthani, Assistant Professor in Mechanical Engineering Department at Dr. Subhash Technical Campus, Junagadh. I welcome you all in the presentation related with the subject Operation Research. So friends, this is our third lecture related to the topic Transportation Problem. So in our previous lecture, we had studied northwest corner method, which was used to obtain the basic feasible solution. So in this particular lecture, we will discuss the second method, that is least cost method, and this method is also used to obtain the basic feasible solution to a given transportation problem. So let us discuss this method. In this method, how the allocation is done. In this particular method, the allocation is done by considering the lowest cost cell from the transportation table. So the table will be given in the data to you, the transportation table will be given in this particular method, and allocation is done to the lowest cost cell. Lowest cost cell means in the entire table, the cell with the lowest value, from that we will start doing the allocation. So from there only we will start doing the allocation in the table. This method reduces the amount of time necessary to arrive at the optimal solution as compared to northwest corner method. Here amount of time that is required, that is less. So now let us see about the steps with the help of which you can solve the problem. There are various steps that we will see one by one. So the first step is select the cell with the lowest transportation cost among all the rows or columns of the transportation table. So the entire table will be given in the data, and from that select the cell with the lowest cost among the rows or columns of the transportation table. So selecting the cell with the lowest transportation cost. So that is the first step to start solving the problem. Second, allocation of as many units as possible to the cell that is determined in the step 1. So once you have determined the cell with the lowest value, then allocate as many units as possible to the cell which you have determined in your first step, and eliminating the row and column in which the supply is exhausted or demand is satisfied. So you will be given in your transportation table, there will be a source and there will be a demand points. So from the source, if the source supply capacity is exhausted, then accordingly that supply will be deleted or that row will be deleted, and accordingly if the demand of warehouse or destination point is satisfied, then that particular column will be deleted. So that is the second step. Third step is, if in case of a tie among the cost, so if in the whole table you find that there are two values in the cell that are same and that both are the lowest. For example, you find in the whole table that the value is 10 and in another cell also the value is 10. So in case of a tie among the cost, select the cell where the allocation of more number of units can be made. So you will have to decide in which cell you can allocate more number of units. In that particular cell you will have to do the allocation. So this is our third step if it is in case of a tie. Then fourth step, repeat steps 1 and 2 for the reduced table until the entire supply and demand at different warehouses is satisfied. So you continue the step 1 and step 2 process and continue till the supply at the different factories are exhausted. For example, if you are having 3 factories, if all the 3 factories supply capacity is exhausted, then that factory will not have any further capacity to supply the items, and at the same time the demand at the warehouses is satisfied. So continue till all the factories supply is exhausted and all the requirement of the demand points or warehouses is satisfied. So till that much time you will have to do the allocation. So this is all about the steps which will be used to solve the problem using the least cost method. Again I am repeating, this least cost method is used to obtain the basic feasible solution. This is the second method that we are discussing. Total there are 3 methods. So now let us move towards solving an example using least cost method. So you can see the data is given. Use least cost method to find out the basic feasible solution for the given transportation problem. So this is the table that is given to you in the data. There are 3 factories. This was the same example that we had solved for the northwest corner method. I am keeping the data that is same, but now we are solving this example with the help of least cost method. So there are 3 factories, namely F1, F2 and F3. There are 4 warehouses, W1, W2, W3 and W4, and there is supply capacity of each factory is given at the end of each row, and the requirement or demand of each warehouse is given at the end of each column. So you can see over here, demand of each warehouse is given over here, and supply capacity of each factory is given at the end of the row. So for F1 the supply capacity is 11, for F2 it is 13, and for F3 it is 90. For W1 the demand is 6, W2 it is 10, W3 is 12 and W4 is 15. And here if you make a total of supply and demand, that is equal to 43. That is called Riemann condition, in which the supply and demand is equal. That is called Riemann condition, and it is also used to check whether the problem is balanced problem or not. So our first step of the solution of this method is checking out whether the problem is balanced problem or not. So you can check it by making the summation of demands of all the 4 warehouses and summation of the supply capacity of all the 3 factories, and that is 43. So here the supply as well as demand is equal, so you can say the problem is a balanced problem. So that is the first step to start solving the problem. So in this case it is a balanced problem as the supply is equal to the demand, and that is 43. Second step, now in this method we will start the allocation by selecting the cell which has the lowest cost. So select the cell with the lowest cost in the transportation table among all the rows and columns of the table. So you can find in this whole table the cell with the lowest value is this one. So that is F2W3. So here the lowest cost is in the cell F2W3. Next slide. So now we will start doing the allocation from that particular cell, that is F2W3, and now for that we will have to check which value we will have to allocate. So you can see factory F2's supply capacity is 13 and warehouse W3's demand is 12. So from that 2 values, whichever is the minimum, that value we will allocate in the lowest cost cell. From 13 and 12 the lowest value is 12. So we will allocate the value 12 in the lowest cost cell in the table, and that is 12 over here. So now you can see this warehouse W3's demand is satisfied, so we will delete this particular column in our next step. So you can see now F1's capacity is 11. Now F2 capacity remains only 1 because we have already allocated the value 12 in the cell. F3 capacity remains as it is. So substituting the minimum value, that is 12. So from the table we can see that demand is satisfied of the column 3 or warehouse 3, and we will redraw the table, and that table will be the reduced table, and that is available in our next step. So you can see from the table over here, as the demand of warehouse 3 was satisfied in our previous step, so now we have deleted that column and we had redrawn the table. So F1, F2, F3 that remains as it is, W1 it is as it is, W2, now W3 is deleted because its demand is satisfied, and then W4. Now other values are as it is. Factory F1's capacity is 11, that is as it is, but now factory F2 remains with supply capacity of 1, that was obtained in the previous step. Then F3 as it is, and its capacity is 90. Warehouse 1's capacity is 6, 10 and 15. Now again the same step, identifying the cell with the lowest value in the transportation table. So now you can see from 21, 16, 13, 17, 18, 23, 32, 27 and 41, the lowest value is in the cell F1 W4. So in F1 W4 you can see that it is containing the lowest cost in the entire table. So we will allocate over there. Now you can see the requirement of warehouse W4 is 15 and supply capacity of F1 factory is 11. So from 15 and 11, whichever is the smaller value, that value we will allocate in that particular column, that is W4, and in the cell F1 W4. So the minimum value that is from 15 and 11, that is 11. So we have allocated 11 in this cell, and accordingly you can see now the supply capacity of factory F1 is exhausted, so it becomes 0, but still for warehouse W4 the demand is remaining, that is 4. So redrawing the table in our next step, in which we will reduce the table by deleting the row F1 because its supply capacity is already exhausted and it is 0. So that's why we are removing that F1 row in our next table, in our next step. As we can say from the table that F1 capacity is exhausted to 0, so deleting F1 row and redrawing the table. So the reduced table in our next step will be like this, which looks like this, in which now factory F2 and F3 remains with supply capacity 1 and 19. Similarly, warehouse 1's requirement is 6, warehouse 2's requirement is 10, and warehouse 4 still its requirement remains, and that is 4. That was obtained in our previous table, that was this. Now again same procedure is followed. Low cost cell in the entire table is 17. You can see 17, 18, 23, 32, 27 and 41. So the lowest value, or the cell with the lowest value, is this one, F2W1. F2W1 having the lowest value in the cell. And now doing the allocation, you can see factory F2's supply capacity is 1 and demand of that particular warehouse W1 is 6. So from 6 and 1, the smaller value is 1, so that's why we have allocated 1 value in this cell F2W1. So you can see now F2's supply capacity is exhausted completely, so we will delete this F2 row in our next step when we redraw the table, but still W1's capacity remains 5. Still it requires not capacity, but still W1's requirement remains 5 because we had just allocated 1. So still the demand of warehouse 1, that is 5, that is still to be satisfied. So redrawing the table in next step, now we remain only with the one row, that is F3, Other values are as it is 32, 27, 41. Its supply capacity is 19. Now warehouse 1's requirement or demand is 5, warehouse 2's requirement or demand is 10, and warehouse 4's demand is 4. So now from this table, the cell with the lowest value from 32, 27 and 41, the lowest value is 27, so that is F3W2 cell that has the lowest cost in the entire table, and we will do the allocation. We will start doing the allocation from that cell, that is F3W2. Now you can see that W2's requirement or demand is 10 and supply capacity of F3 is 19. So from 10 and 19, whichever the value is smaller, so you can say that 10 is the smaller value, so we will allocate the value that is 10 in that particular column, that is of warehouse W2. So now you can see that W2's requirement was 10 and you have already allocated the value 10 in that particular column, so warehouse W2's requirement is satisfied. So now we will delete W2 row and we will redraw the table in our next step. So allocating minimum value from D2 S3, that is 10. So now warehouse W2's requirement is satisfied, so deleting W2 column. So again we are redrawing the table. In that factory F3's requirement, now you have allocated 10 from the 19, that was the capacity of F3, so now remains 9. So F3 with 9 supply capacity is still there, and now W2 column is deleted, so we will remain with only 2 columns, W1 and W4. Other values are as it is, 32 and 41. The demand of warehouse 1 was 5 and for warehouse 4 it was 4. So now the cell with the lowest cost from 32 and 41, that is 32, so that is F3W1 cell. It has the lowest value in the entire table, and we will do the allocation over there in that cell. So the demand of warehouse 1 was 5 and the supply capacity was 9. So from 5 and 9, the value which is smaller, that we will allocate. So 5 is allocated over here because it is the smaller from 9. So 5 is allocated in this cell. Now you can see okay, warehouse 1's demand, that was 5, that is satisfied. So we will delete that particular column in our next step and we will redraw the table. Now still the supply capacity of factory F3 remains, that is now 4. So going to the next step, now W1 is satisfied, so we will delete the column W1 and we will redraw the table. Now in our next step, you can see now W1 is deleted, now only remains factory F3 and warehouse 4. Now supply capacity of F3 is still 4 and the demand requirement of warehouse 4 is 4. So 4 is the supply capacity of factory F3 and demand of the warehouse 4 is also 4. So you can allocate 4 in this particular cell, that is F3W4. So you are allocating the 4. Now you can see demand is 0, of demand is already satisfied of warehouse 4 and supply of F3 is now also 0. So it is exhausted. So as all the factory supply is exhausted and the requirement of all the warehouse is satisfied, so we will stop the allocation process. So now I have redrawn the table, entire table that was given in the data, and I have put on the values which was allocated in various steps. So the whole table is redrawn again and I have done the allocation accordingly. So you can see in this particular cell F1W1, in this particular row the allocation is in F1W4, so that is this 11. Then second allocation was in F2W1, that is this Third allocation was in F2W3, that is this. Fourth allocation was in F3W1, that is 5. Then fifth allocation was in F3W2 cell, that is 10, and sixth allocation was in the cell F3W4, and that was 4. So we are having 6 allocation. Next step, and feasible solution which contains m plus n minus 1 non-negative allocation is called basic feasible solution. That problem is said to have basic feasible solution if and only if it contains m plus n minus 1 non-negative allocation. So we are checking that whether this feasible solution is having basic feasible solution or not. So that is formula that is used to obtain or to check whether the feasible solution is having the allocation, that is m plus n minus 1 non-negative allocation. 3 plus 4 minus 1, 3 m stands for number of rows, n stands for number of columns. So there are 3 rows and 4 columns. So we are having 6 allocation. So that you can find from this entire table we are having total 6 allocation, 1, 2, 3, 4, 5 and 6. So you can say this problem is having a basic feasible solution. Now feasible solution is what? Again there may be a question. So feasible solution, the problem to have a feasible solution, the condition is that it should satisfy the RIM condition. And RIM condition is what? The supply capacity should be equal to the demand requirement. So this is having a feasible solution also, and the feasible solution is said to have a basic feasible solution if it contains m plus n minus 1 non-negativity allocation. So that is also checked over here using this formula, that is m plus n minus 1. So we are having 6, and that is can be seen from the main table. We are having 6 allocation. Feasible solution is one which satisfy the RIM conditions. Then Xij should be greater than or equal to 0, so that is called non-negativity constraint. It should also satisfy supply constraint and demand constraint. So if it satisfy all the 3 constraints, then the problem is said to have a feasible solution. Now we are obtaining the total transportation cost. So 13 multiplied by 11, 17 multiplied by 1, 14 multiplied by 12, 32 multiplied by 5 plus 27 multiplied by 10, 41 multiplied by 4. So if you make a summation, it will give you 922. That is the total transportation cost. So what is Xij? Xij, that is, I have already sorry, this is a mistake over here. The thing which is shown in bracket, it is equal to Xij. There is a mistake. Xij is shown in bracket, here it is shown Cij in the bracket, but that is mistake. The thing that is shown in bracket, that is equal to Xij, and outside this value is actually Cij, but it has been reversed, so that is mistake in this. So the thing which I have shown in bracket, that is not Cij, but it is Xij, and outside the bracket, that is Cij. So Cij is what? The unit cost of transporting from I to jth destination, and Xij, that is number of units that is transported from ith destination to jth destination, such that the total transportation cost is minimized. So this is Xij, that is 11. Okay, this is all about least cost methods example. I hope this method is clear to you now, and I insist you to practice this methods example from whichever book you are convenient for your betterment. The more you practice, the more you will have the confidence level.